We're going to be talking about the experiences that implementers had at the last NMOS workshop that was held in Porto in Portugal, where participants were implementing the AMWA NMOS BCP 008 minimum status reporting specifications. So we had both native implementers and also people using nmos-cpp there, which we're going to talk a bit about. And we're going to point you to some of the development resources that we've got available that you can use in your own implementations, and a little bit about the NMOS testing tool for kind of proving that your implementation is correct. So I'm Jonathan Thorpe. I'm a software architect with NVIDIA, and I'm here with Cristian. Cristian, you want to say a
Yeah,
few words about
hi.
yourself?
I'm a tech lead at Pebble, and we've both been in NMOS for many, many years now, many activities. Uh, so yeah, and including MSO5, IS12, BCP08 more recently. So yeah, we would love to share some useful details and learnings from our experiences throughout these activities and the recent workshop. Yeah.
Great. So, Cristian, the BCP 008 specifications are part of the NMOS control and monitoring ecosystem. Maybe you wanted to sort of start off with a high level overview of that.
Yeah, I think that would be a great idea. And that gets me talking about one of my favorite diagrams. I might want to share my screen briefly. Is that coming through?
Yeah, I can certainly see that.
Okay. So yeah, as I said, this is one of my favorite diagrams. I call it the serpent diagram. And it allows us to talk about these pieces, the pieces of these NMOS control and monitoring ecosystem. So let's talk about these three things on the bottom left corner first and how they neatly fit together. So we've got MSO5, which is our modeling framework. And that really is where we've established the vocabulary, the basic data types, the basic classes, and how these can be combined together to model a particular feature or a particular piece of functionality in an NMOS control device, right? So that's a very important base piece of our ecosystem, and the protocol and everything else kind of builds around it. Then we go into IS12, as we mentioned earlier. So that's our communication protocol that uses WebSockets, and we pass around JSON messages around bidirectionally, so backwards and forwards, also supporting notifications. So we move away from that kind of ancient polling paradigms. And last but not least, as you've just mentioned, BCP08, right? So our most recent, well, some of the most recent specifications, definitely the most recent in the NMOS control and monitoring space, which is BCP0801, the receiver monitoring spec, status monitoring spec, and BCP0802, which is the sender monitoring spec, right? And these really are places where we can capture feature set models. So the models that we agreed on as minimum models for monitoring a receiver and monitoring a sender, but also because it's a BCP, a best current practice specification, we can capture behavior. So things like what happens when you activate a receiver, what happens when you deactivate a receiver, how do you map these statuses around, how do you kind of capture historical status and so on. So these three are kind of the mainline pieces of the puzzle that then combine together to allow kind of this multi-level interoperability and convergence, right? So at each of these levels, we try and get devices to converge: the modeling layer, the protocol layer, and then the behavior layer. Now, if we look at the right-hand side, that's basically how we allow flexibility in implementations. So vendors are still able to create their own vendor-specific pieces of functionality. They can build on top of the standard ones and add vendor-specific elements, vendor-specific properties and methods. But these can still be identified as the baseline classes that they derive from. And the additional pieces of functionality can also be discovered generically. So a controller can also work with these additional features, right? So that allows us to kind of get the best of both worlds. We can get maximum interoperability, and we can also allow these elements of flexibility. And I should probably say that this kind of goes into the long-term strategy. So BCP08 we think might be just the first feature that we can then expose in this feature set register, as we call it. We could think of other things that we could standardize and converge on. We can think about gain controls, RGB controls, or even working with tally lights in the multi-view, or UMDs and tally lights. So many more, I think, will follow, and BCP08 is just the beginning. So should we now try and quickly summarize some of the aspects of BCP08 in specifically, Jonathan, for our audience?
Yeah, that sounds like a good idea. So when developing these specifications, the goal was to try and keep the statuses simple. So we wanted to reflect the most important aspects of NMOS senders and receivers. And so it was decided to go for just very simple statuses, like a traffic light system, red, amber, green, healthy, partially healthy, unhealthy. So I mean, it's relatively self-explanatory what healthy and unhealthy is. Partially unhealthy, well, I mean, for instance, if we have two legs of our media network and one of them goes down, but the other one is still up, well, it might be we still our receiver is still receiving essence, but it's partially healthy because actually one of the legs has gone down. So we can use those simple statuses to reflect what's going on with our senders and receivers. So if you go to the next slide there, Cristian, thank
Yeah,
you.
sure.
So this is kind of showing the receiver monitor, which is we have, as Cristian said, we have the receiver monitor specification and the sender monitor specification. This is showing you the different statuses that the receiver monitor has within its data model. Now it has we've not gone into a great deal of detail about the MSO5 kind of modeling that underlies this, but it's effectively it's object oriented. So we have a base class, the status monitor, that the receiver monitor is derived from. And that status monitor has an overall status. And that overall status just encapsulates all of the other statuses within the receiver monitor. So if everything's healthy, fantastic, our overall status is healthy. But if one of those statuses in our receiver monitor is partially healthy or unhealthy, that will be reflected in the overall status. So it means at the bare minimum, we just have this one parameter that we monitor in order to see the overall status of our receiver. But then when we get into the receiver monitor, we can see we've got different status domains. So we have statuses reflecting connectivity, synchronization, and stream validation as well. And yeah, without getting into too much detail about MSO5, if a vendor so chose, they could derive their own monitor from the receiver monitor and add extra properties to it if that's what they wanted to do. So Cristian, we recently had our NMOS control workshop event in Portugal, which went really well. It was really
Yeah.
successful. So should we talk a little bit about the things we learned at the workshop and some of the results that we saw?
Yeah, I think that would be a great idea. So I put together a little picture as well. So we had a couple of days in November where we got together in the Porto district at this event that was held by our friends at Bisect. And it was really a lovely place of the world to be in, and really welcoming guests and lovely food. Yeah, this is kind of the area where we're in, and I just took a picture of the bridge we crossed after our evening dinner. And just to make a little joke, some of our tools later on will run in containers, so it's kind of relevant, I would say. Yeah, so it was a great couple of days, really. We had 6 vendor participants and a few others actually who wanted to join, but the timings kind of clashed with some other engagements. And this is really one of the reasons we wanted to do this webinar, is to kind of bring some of those learnings and that valuable information that participants had access to speed up their developments and their bootstrapping their implementations to kind of a wider audience, right? So interoperability results were very, very positive. I was really impressed by the participants. I mean, they got working implementations that could run the test suites in only a few days. Yeah, some of them coming fresh, right? We had a few participants that weren't really in the original activity groups, so I think that was really impressive out of everyone there. We had 3 media nodes passing the NMOS testing tools, so passing the IS-12 test suite, the BCP 0801 test suites, and BCP 0802. We had 3 controllers and 2 simple clients that were monitoring BCP 08 in an interoperable way, so interacting with these media nodes. But also, I think that the thing that really impressed me was that actually we went beyond this. So we had interoperability beyond just BCP 08, including things like control and vendor-specific control. So controlling things that a vendor explicitly enables and exposes for their particular device, right? And that has to be discovered and used in a generic way. So that was really, really good. Uh, and yeah, it was really good. And I think we should probably start sharing some of those learnings and look at some of those artifacts from coming from the workshop. What do you think?
Sounds like a good idea. Shall I quickly share my screen? And
Yeah, I think so. Yeah. Let me see. Stop.
okay,
I'll bounce it to you.
great. So hopefully you're seeing
Yeah.
my screen. So I'm just going to give you an example of some of the things, the types of things we covered in the workshop. So for vendors who are aiming to create their own native implementations, it was important to get a feel for how IS-12, MSO5, and BCP 008 all kind of work together. So this is the sort of worked example we went through with the participants. So here we have a diagram that shows an NMOS controller and an NMOS node. And in that NMOS node, we have a control endpoint. We have an MSO5 device model and the BCP 008 behavior. If I just, yeah, so here we see the device model, which is a hierarchical set of objects. So each of these objects, we can see we've got a root block, and in that we have a receiver monitors block, and in there we have a couple of receiver monitors. And then each of these objects has methods, properties, and events that are identified by kind of method IDs, property IDs, and event IDs. So the controller connects to the node using a WebSocket, and then over that WebSocket, it can issue commands, which are just a chunk of JSON, and then that will receive a command response, which is just another chunk of JSON coming back the other way. The controller can also subscribe to objects within the device model so that if there are any changes to properties on those objects, they will receive a notification. And if anything goes wrong, well, we have error statuses that we will return in that eventuality. And in the back here, we have the BCP 008 behavior. So there are various things defined within the specification that aren't really covered by the device model alone. So things like status reporting delay, activation and deactivation of senders and receivers are all kind of handled outside of the device model. So for instance, in NMOS CPP, we have a behavior thread that kind of deals with all of those bits of functionality. So yeah, just kind of going through the flow of how the controller talks to the node. We have our WebSocket connection into our control endpoint, and that creates a session that is stored in the control endpoint, and we can then issue commands Here we have a command where we want to invoke the set method to set one of the properties. And this chunk of JSON kind of encapsulates that, targeting a particular object by using its object ID, and then using a method ID to target the method. And then here we have an ID to target the property that we want to change. And once that's changed, we get the response coming back to tell us that that's happened successfully. We can also create subscriptions. So when we create a subscription, we tell the node which objects we're interested in. So that gets stored by the control endpoint. And we get a subscription response confirming that we've successfully subscribed to that object. But if a property changes within the device model, that creates a property change event, which then will be notified to any connection that has subscribed to that object as a notification. And so you can see from this mechanism the sort of the basis of the BCP 008 status monitoring, that all of those statuses, as they update, they can generate notifications for controllers that have subscribed to those objects. Okay, so I think that's
Yeah, that was a great, yeah, great set of slides. And I think one thing I wanted to add there is that because we've done all of this work up front to think about the modeling framework and then combine that with the protocol, we had almost like a platform ready to use to solve problems. So when BCP08 as an activity kind of started, right? We managed to, I don't know how you feel about that, but I thought that that went really smoothly because we didn't have to worry about coming up with another modeling framework, coming up with another protocol, coming up with the schemas and everything else. We could purely focus on the problem space and come up with the actual solutions to the problems that, the user requirements were bringing to the table. So I thought that was a really, really nice way to do it and chain these activities together.
Yeah, absolutely. And certainly I know the experience of implementing BCP 008 in NMOS CPP was very straightforward because we'd already got IS-12 and MSO5. And once you've got those, then the pieces of the jigsaw just kind of slot into place. And it's
Yeah. And
yeah.
hopefully that's what our workshop participants found as well, is once they got the modeling framework kind of implemented, then it's just a matter of plugging in more models, more features, right?
Yeah. So did you want to say a little about the separate tracks that the workshop had,
Yeah.
Christian?
Yeah. So I think when we thought about planning the workshop and obviously working our way with the participants and what their interests are, and if they're making media nodes or if they're making controllers, we wanted to keep this tradition alive of NMOS, which is that it's open, but also incredibly flexible in the way you approach these specifications, right? So we've had NMOS CPP for a while now. It's our, I would call it SDK-like experience. I don't know if that's a
Yeah.
good terminology. But yeah, it's a library that is extremely robust. It's thoroughly tested. It's got thorough CI/CD pipelines that kind of test it. So that was always going to be ready and there for people to use from an application layer and, build things on top really, really quickly. And you'll probably be able to talk a bit about that in a minute. But we also wanted to offer people the alternative, which is if they wanted to implement this natively in their own frameworks, right? They're free to do so, and that has implications, as we'll see later, on how we ensure interoperability and how we kind of adapt around that ecosystem. So in the end, we had effectively three implementation tracks. Sorry, we had the NMOS controller implementation tracks. So we had a few controller vendors there. They were looking at implementing this from the client side. We had media nodes using NMOS CPP, as I've just mentioned. So that is kind of probably the easiest way to add this capability into your nodes, because effectively you're just doing integration on the application layer. And then we had media nodes with native support, right? So all of those three tracks you wanted to support, and actually we had participants in all of those tracks. In media nodes, they're, I would say, equally split. All the tracks split into kind of core milestones, so a minimum set of requirements that people kind of got to during those few days, and some kind of beyond that. Those would kind of span things like advertising, discovering the control endpoint, sending and receiving some commands, and tying them up with responses. And in terms of the further milestones, we had a set of further milestones to kind of go beyond that. You had things like iterating through the device model, so showing all of the objects, how they're nested and their properties, and then performing class and data type discovery, so you can work with things like vendor-specific classes generically, right? As I mentioned earlier, we managed to show that interoperability level as well. Uh, I would say in terms of languages, it was very, very diverse as well. So, we had things like C++, C Sharp, Python, Rust, TypeScript, Go, JavaScript. So we had many, many languages that participants used at the workshop, which was great to see. So what was your perspective from kind of the NMOS CPP side on
Yeah.
this?
Yeah, so I think I was just really pleased and impressed at how quickly participants kind of got something working in like no time at all. Um, I mean the benefit of using MLCPP is all of that kind of groundwork of IS-12 and MSA5 has all been done for you, and actually implementing BCP 008, it's kind of just like a few lines of code really to get it working. I think looking at
Yeah.
time and we've had quite a few questions about kind of development resources and examples. I think what I might do is just jump straight to just illustrating by um,
Yeah.
showing the resources that if I click share. So so in terms of the resources that we used in the workshop, so NMOS-cpp was the one that was being used. So NMOS-cpp is an open source implementation of NMOS that was developed by Sony, and that's over the years that's kept pace with the NMOS specifications that have come along. So it's always sort of up to date with the latest specifications. Um, so if you want an example of kind of a working NMOS node that implements a whole range of NMOS specifications, but including IS-12 and BCP 008, this is a good place to start. For the workshop, I did actually create on my fork of NMOS-cpp, I did create a branch called AMWA Workshop 2025. And in that, I had kind of like a bit of some scaffolding, I guess, for want of a better word, that to give like a gentle introduction to how the steps you would need to go through to create BCP 008 device model for your NMOS node. So that might be worth looking at.
Yeah, and
And
I'll
the
put
other
my hand
tool,
up. I've used that before the workshop as well. And it also supports vendor-specific classes from what I remember. So that was easy to add using NMOS CPP.
yes, yeah. It's slightly more involved, but there are examples in the code of how to create your own objects. So if you want to be able to do that, you can do that.